Good morning, good afternoon, good evening, depending on which part of the world you're in. Welcome to episode 64 of Unboxing AI. This is Dhruv Sahai, CEO at Carpal, and I will be your host for today. For those of you who do not know about Carpal, oh, shocking. Carpal is the world's largest radiology AI platform and marketplace, and the only healthcare AI platform with an FDA clearance as well as a CE mark. In today's episode, we have the pleasure of speaking with Dr. Xiao Chen from United Imaging. Dr. Xiao Chen is the Director of Clinical Research and Collaboration, as well as the Principal Expert Scientist at United Imaging Intelligence. He has over 15 years of experience in the medical imaging industry. He has led the development of some cutting edge AI algorithms and products for image analysis, post processing, and image reconstruction. He plays a key role in bridging advanced research with clinical application, driving innovation that enhances diagnostic imaging and patient care. Dr. Shen, over to you. Why don't we start with the introduction of yourself?
Oh, thank you, Drew, and thank you for inviting me to this platform to communicate with some colleagues and people that is interested in the AI for medicine domain. So my name is Xiao Chen. I have a PhD degree in biomedical engineering. So I graduated that was like 20 years ago, so quite some long time ago, and after that, so my PhD was very much focused on cardiac MR investigations. So I developed some algorithm for fast imaging. If you recall some, we call old era algorithm called compressed sensing. If you know about that, so that's when compressed sensing basically just started for the MR domain. So my PhD thesis was focused on the fast imaging for the heart, and I have some work that managed to speed up the acquisition by 10 times, which is quite a lot. And after that, instead of focusing on the MR, I went to Siemens, the research center of Siemens Healthcare in Princeton. So there I was a research scientist for 5 years. I had an amazing experience there, and it definitely broadened my view of the medical domain, and not just focus on MR, but also on the other parts of the medical using artificial intelligence. And after that, after 5 years, I moved to Boston, which is currently now in United Imaging Intelligence, as a research scientist and also a director of the clinical research and collaboration. Here, I'm in charge of several products that we develop to fully automate the radiologist reading process, and also leading researchers for our customers, clients, to better use our tools to let them, do research, to explore, to extend the front line in this domain. Yeah.
Wow, that sounds amazing, Dr. Shen. And 15 years of experience in the industry from Siemens to now United Imaging. I mean, we would love to hear more about your career journey, some interesting anecdotes, during the 15 years that you've spent in the industry. We'll also have young radiologists listening in, and it would be great for them to, learn something from your journey.
Yeah, sure. So I would be happy to share that. So let me go back to 20 years ago, right? So I was a PhD student, and the training actually includes basically the whole suite of MR training, which means that I actually operated on human beings, although I'm only certified to operate on healthy volunteers. But at the very end of so basically my journey of the algorithm part instead of the hardware part start from the mid of my PhD. So that my PhD advisor basically handed me a paper, says, this looks quite cool. Would you like to take a look at it? So at that time, compressed sensing, it's just was introduced to MR domain, and I'm basically the first few or the only ones in the whole university that is working on this topic. So I, went through the paper, the math, everything, and then, basically developed this stuff in the lab and also in the department and also in the school. And at the very end of my PhD, I still remember that day that we were testing my algorithm on the scanner in the hospital session. And there was a very old couple walked in, and they were scanning, and we had they agreed to participate in this research topic. So my sequence was running on them, and there my basically my technique revealed that the uh, the old couple, one of them, has a very severe amyloidosis in their heart, and their life is only probably the life expectancy is only like 6 months more. So that shocked me. This is the first time ever to me that I feel that my work is so close to everyday people's life, and I decided to to continue on that journey. And I don't want just be, let's say, in the lab and dealing with algorithm. I want to work out and actually be involved in the process. So that's why I chose industry in for my next stop, and I joined the Siemens. And I would say there is some fortunate there that the topic, the part that I joined Siemens is not just focused on one modality, one MR scan, like one type of medical imaging, but it's more broad and can touch CT, MR, different kinds of modalities, and starting to develop algorithms for a more, let's say, general purpose. And that basically, I would say that's walking out of the comfort zone for me, because a lot of the my colleagues, the smart minds, they are coming from, we are all coming from different backgrounds, mostly on computer science, electric engineering. I'm from biomedical engineering. So there's a lot of things for me to learn, and I definitely, I would say I gain a lot of knowledge and capability during that time, which prepared me for the current job that now I'm leading, the product as in UII. And just for the audience that is not very familiar with UII, it's called it's United Imaging Intelligence. It's one subsidiary of the United Imaging Group. So United Imaging is a huge group. It has several companies underneath the umbrella, right? And the United Imaging Intelligence is basically an AI company. So we don't make those scanners. We focus on the medical AI solution. URI is a AI company basically. So we are still considered as a startup, although we are in the big umbrella of the huge, United Imaging Group. So in this sort of like a startup style company, um, my all form of experience basically prepare me for a let's say the capability to handle to take more responsibilities. And I would say fortunately that my biomedic background gave me the advantage of basically talking a similar language as our radiologists and cardio or doctors they use, right? So I can understand their needs, understand their feelings better, and so I can bring this into the company and see how our product can fit into their workflow, fit into their needs to better help them, instead of we just develop our own algorithm and we just throw the products to our clients. Yeah, so that's something that I hope I shared can be a little bit help for the young audience, and there's maybe some students there and still deciding your career path or where you can go. I would just encourage you to go expand your horizon, to go to different domains, and don't be frustrated by a few let's say declines that you may get during the process, because it may just not, you may not still find the best fit for you, but your capability will fit and shine in somewhere. Yeah.
I think Dr. Shen, that's terrific advice, and I'm 100% aligned with you. I was when I was listening in, it certainly seems like you chose what you do for a very noble cause, and it's amazing. And now from that context, I do want to understand your perspective, and I think it is very interesting for our viewers as well to understand your perspective on AI adoption. AI has been there for a while. We are still at the early adopters curve, I mean, globally. And as a doctor, how do you feel that AI, I mean, what are the pros and cons of adopting AI?
Hmm. So yeah, as you said, that AI has been there actually for a very long time, and there are some hypes and downs through the journey. Um, Currently, I would say that when we talk about AI, we're mostly talking about the deep learning based methods, right? Um, it does have a huge impact, I would say, improvement comparing to the previous algorithm, and that's why it generates a new wave of interest into this. And from our experience, that we do see the current AI or the current deep learning leaded solutions definitely brings a lot of changes to the radiologist workflow, their their reading behaviors. And we have certain examples, I mean, products that we develop here. For one example, that is the cardiac MR, cardiac magnetic resonance imaging reading. So CMR, as for cardiac MR, is very challenging to do in the way that uh, quite some hospitals they are reluctant to do CMR. One of the reasons is it's slow to acquire, but the another big reason is that it takes super long time for the radiologist, or in sometimes is the cardiologist, to read the images, because CMR provides different contrasts. It's like hundreds of images, and each one of them looks almost completely different. I mean, that's one of the power of CMR, is that it provides very comprehensive analysis, but it's a huge burden on the reader. The reader needs to be trained to know what is a T1 weighted image, what is a LGE, what is a T2 weighted, and the highlight signal in one image, it means healthy tissue, but on the other contrast, it means completely opposite. It may mean this is a scar tissue. So all those stuff, right? It usually takes the doctors may take over 30 minutes or even longer to do this. So the hospitals, especially in developing countries, and not the first tier hospitals, they're reluctant to do this. They don't want to do it. They have the bandwidth, they have the capability to do the scan, but they don't want to prescribe this because it takes too long. So what we developed a fully automatic CMR analysis tool. When I say fully automatic, it's really that you just need to finish the scan. You push the whole data set to the software, and the software will pick out what is the right sequence for what analysis. And then for each analysis, it does the job fully automatically. Okay. And then we present the results to the radiologist or the cardiologist. We do basically the tedious, the contouring of the myocardium, the some organs out. We highlight the regions that is susceptible for disease. We summarize the numbers on the other side, on the right side, on the same screen. So very quickly, the cardiologist or radiologist, when they read the images, they can just get a glimpse of, what is going on. They can evaluate whether the algorithm is doing right or wrong very easily by looking at the contours, or by comparing some of the parameters they have, right? And from our experience, many of the times they only need to change a little bit of the results the fully automatic process they provide, right? And then the reporting system can also summarize the results beautifully. You can customize it. You can add into the figures that you want, and it will generate one. And that takes, like, I would say, less than 5 minutes, because most of the time when the patients leave the table, I mean, get off the scanner, and by the time the radiologist, cardiologist start to look at the images, the result is already there. So it's super fast comparing to, some existing, I would say, the previous era machine learning provided solutions. They can only provide you probably, just certain contours, certain results, not everything, and it still require the user contour on the images for 1 to 2 frames, and there is some quite some high percentage of failure cases. So the current the power of the current algorithm is, I would say, on another stage comparing to the previous era, and which I won't say that this can just fully automatic everything, right? We still need the radiologists, cardiologists to read the images to make the decisions, but definitely release a lot of their time and open a lot of doors for possibilities for the hospitals to reconsider certain techniques and the applications that they previously were reluctant to do. So I think that's the current impact of the AI, and why it's I think that is different comparing to previous period. But acknowledgeably that there is still a lot of things that we can do and we need to do in this domain. There's a lot of hypes, achievements achieved in the natural image domain, like the Google. Your camera is your camera on the cell phone is much smarter now. That when I take a picture of my son, I can very easily remove the background, people by just one click, right? Um, those stuff we are cannot be easily translated into the medical domain, because the medical images and the natural images, they are very, very different. And the knowledge and the database that we have in the two domains, in the natural and the medical domain, is very, very different. Okay, so I would say there are definitely very bright future for the AI in the medical domain, but we need to work on that hard to get there. Yeah.
It's interesting that you just said that, while there are several advancements that have been made, you still can't automate the entire process. A human in loop is required. And interestingly, I get asked this question so many times by so many people on, would AI take away their jobs? And I also, give them the same answer. What's your perspective on this? I know this may be a bit of an edgy question, but it would be interesting to hear your thoughts on it.
Um, I mean, we are all scared by the current, development of AI, the large language model. I mean, I guess we all use some certain type of ChatGPT daily, right? So my feeling there, and also even for our product development, we're using, those tools to assist in the development. And so my personal experience, just from let's say, if you want to ask me, will AI replace a scientist? I would say no, because it's not just about the capability. It's about um, what the job is asking. Maybe we need to redefine what the job is about. We need to redefine what a scientist job is, right? But it's not say that we replace a scientist there. So I think that's some mindset that we need to change. And the same for the in the medical domain. I really like the one comments there is that it's not going to replace radiologists. It's only going to replace radiologists that don't know how to use AI. So the knowledge in the radiologists, in their mind, and also their job is not just by reading images, right? It's not just by contouring, which part is what. That's not what the only part of the radiologist job is. They have they they I mean, our algorithm, the development of AI, is only to their time in those tedious work, in the work that is repeatable, that is laborious, and and to help them to do better to their job, and they can based on the current technique, the tool to expand their job scope, right? So that's my feeling here. So I don't think this will replace any job. It may replace certain people that is not catch up with the current development, but it's not going to replace certain the human parts, the job. Yeah, that's my that's my
That's
feeling
exactly
of
the
this.
same
Yeah,
answer that I give to everyone when I
it's the
ask
same.
ask
Okay,
this
great.
question. I tell them the same thing. I said, look, if you don't learn how to use it, then those who have learned how to use AI to their benefit, they are the ones who will take away your jobs. So the best thing is to learn it. I
Yeah.
often compare it to the tech revolution of the early 90s. If you learned how to use a computer, well, you took away the jobs of those who did not know how to use a computer. So
Yes,
great,
exactly,
and
exactly.
Dr.
Yeah.
Shen, we have some questions that have come up in the Q&A section. So I'm going to try and go through as many as we can. There's one by an anonymous attendee who asks, when organizations invest in AI, what metrics or KPIs should they track to measure successful adoption and impact?
Mm. Well, thank you for the question. So I think people tend to use KPIs to measure the success of certain applications. I mean, this is easy to do. It's quick. But in our domain, in our experience, right? So the reason for the role or the part that we need to do clinical research and collaboration is that we treat this as a process. So we don't just deploy our products into the field and we just let it go. Okay. We want to keep, adapting the products, adapting our understanding in the domain because the whole domain is evolving, right? I think that both our clients, the radiologists, or cardiologists, or the users, and us as the solution provider, we are evolving in this domain because everything is happening so fast. So the understanding is changing. The way we are using the tools, the way we understand the AI is changing. So in this domain, I think it's very hard to just say that, oh, I mean, we can set up, certain premises such as the use frequency, like how many cases has been opened by our solutions, right? But the numbers does not translate to everything. Okay, the user may be willing to open their software, but you never know that they may open other software as well. I actually have talked to some cardiologists that I asked them, hey, why do you choose, you know, to open, to look at our solutions instead of the other? They say, no, 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 no. I open your solutions. I open two more solutions as well. I open them at the same time. I look at the results and then I combine them. I combine the results in my mind. They figure out that each solutions has maybe the pros and the cons. They may be good at certain diseases. They may not be good at certain diseases. They open them at the same time. So if you just look at the numbers, you will never know these stories. So that's why the clinical research and the collaboration, we actually, we actually sift through our clients to look at how they work, how they use our tools, what their feedbacks, what their new requirements they are, what their views in the future is. We work with them and we get their feeling. We let them, of course, let them know our tools better. We also let us to know them better, and then we continue working on that. So just to the question, right? So we do have numbers there, such as the example I give, but I won't say that's the solid, the only thing that we look at it. And yeah, yeah.
No, yes, that's great. We have another question by Shruti, who is the director of marketing at Kapil. She asks, how do you measure product success at United Imaging? Is it accuracy, adoption by radiologists, cost savings, or patient outcomes? I mean, I would say it's all of them, but how would you
Yes.
prioritize these?
Yeah. So honestly, this is a little bit beyond my, scope. I'm not an expertise in the marketing and the sales, but I think I would just reiterate part of the what I just talked about, right? So, um, we talk to our clients very frequently. We know their needs. I think in this domain, it's because everything happens so fast. It's really a very continuous efforts in making our product successful. And to achieve that, we have the stage of a very uh, you know I would say in-depth investigation into the domain onto what the doctors needs, and you need to adapt. Trust me, you need to adapt for the product requirements. I mean, in UII, I would say that we have very frequent iterations on the products. You can't believe that we have hundreds of products, and every product they are released on a almost like a quarterly based. And we between the quarter, big versions, we have service packs all the time. And that is not to just fix bugs or something. we have continuous receive. Once we have, products in hundreds and thousands of hospitals, we receive requirements from different area, right? And they may be very different. And we are doing our best to adapt to everyone's needs. We're summarizing them and we put them into the next version, which may be just a month apart. And we are also putting a lot of efforts into developing the next generation products to fulfill, we're trying to push the boundary there. So yeah, so from my perspective, it's very hard to define this as far as I know, but we are working, very closely with our customers. I think that's a key part. I mean, currently our products is deploying in thousands of hospitals in China and a lot of hospitals in other parts of the world. And we know very clearly that different parts, different regions have very different requirements, and the measurement of success is also very different between different regions. Yeah.
No, I agree, Dr. Sen. I think being customer centric because they are at the ground, delivering healthcare. It's essential to be customer centric, understanding their needs. I know we are on time, and I see a lot of questions here. I don't not sure we'll have time to answer all of them, but let's pick up at least one more. The next question
Sure.
is by Himanshu Makkar. Himanshu Makkar serves actually as the director of product at Carpel. He asks, his questions pertain to the workflow part. In fact, something that you mentioned, that during reading the case, were there what were the biggest hurdles that you had to overcome, in the changes in reading workflow with AI adoption? Were these, technical, procedural, psychological, and what made it easy to adapt in the end?
Yeah. Thank you for the question. That's a good question. So I think um, you will feel once you're in the deployment domain, I think you're also very clear that there are variety of bottlenecks there. And I would say by because working in different companies, I would say that it's amazing that certain regions is so open to new techniques. The doctors, they are very open to new workflow, to new technologies. Although I mean in this domain, we also the UI and also I believe Carpool is making the workflow, we are put a lot of emphasis on the workflow integration, right? We're trying to make this seamless because time is very precious to them. So probably the number one challenge or the number one consideration is about the workflow, like how you integrated this into their daily life. Now, currently, our users, most of our users, they are willing to, let's say, click, you know, click on additional buttons and see much more results on a lot of help from our applications. They are willing to do this, but they just keep asking whether our solutions can be merged more deeply into their workflow because they want everything easier, faster, and to leverage the current power of AI, right? So we are also working on that. Just because you are thinking about you can think in a way that the image reading is only, I would say, a tiny part, but it's only part of the disease management, right? You have other EHR, the records, the patient history, all those stuff. You can imagine like how big this can be if we combine things together, and there is a bigger platform there to support the hospitals there and leverage AI, whether it's LLM or it's the vision language model, those hybrid models. And you are also not just looking at one images or looking at one disease, but you are by looking at one image, you're getting all the information. Currently, a radiologist getting maybe not just the cardiac. When you look at the chest, it's not just the cardiac, it's the lungs, it's the thorax, it's the digestive system, different stuff. We're putting this all together. You can imagine how this will be. Yeah.
I think, before we log off, we have time for one last question. And this is by an anonymous attendee again. It says, looking ahead, which areas of AI adoption do you see accelerating the fastest in the next 2 to 3 years?
Sorry, I didn't get the question. So what was the question again?
It says, I mean, looking ahead, what areas of AI adoption do you actually seeing accelerating the fastest in the next 2 to 3 years?
area as in the medical domain or more like a general domain?
I think I would say
Oh,
from the
well,
medical.
I
Yeah.
guess I cannot. Yes, yes, sorry. So yeah, uh, adopting fast. I think we still need, although we are continuously pushing the edge in the of the boundaries, right? Like I said, that we combine all the information together. But I think that we still need to, go step by step. So I think from my current experience that the things still developed fast is about the radiologist reading, image comprehension, those tasks that previously has already been used by the by some machine learning algorithm that give results. Now it's replaced by more advanced algorithms there. But I would anticipate that in the next few years, those applications that can combine not just image or not just one type of image, but like multiple modality images and a different model like the text, the patient history combined with the image findings and generating the reports is going to be the 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 new I would say probably the common for the next few years. Yeah.
Okay. Unfortunately, we are on time. I think 30 minutes is not enough for a conversation. We probably needed more time with you, Dr. Shen. I have a bunch of questions, for thank you for all those who attended. Thank you, Dr. Shen, for joining us and for those wonderful insights. For those of you who would want to see a video of the webinar later, you can log on to our YouTube page. The link has been provided in the chat box. And of course, join us next Thursday for episode number 65. Same time, same place, maybe a different host. Thank you.
Thank you. Bye bye.
Bye.